So here we've been given a graph. We have a bunch of points where we have undefined points, discontinuities, we've got kinks in the graph, we've got asymptotes. So we want to know, we're going to look at J. So we want to provide a limit argument to justify points of discontinuity. And really, one of the things that we can provide for discontinuity really is if the limit doesn't exist, okay? The limit as x goes to a of f of x doesn't exist. If it doesn't exist, it's discontinuous, okay? Now, we can also have different types of discontinuity. So for example, if the limit doesn't exist, okay, and we can say that as x goes to a from the positive side is not equal to the limit as x goes to a from the negative side, that means that we have a jump discontinuity. Okay, so it looks like that. If we can also have discontinuities that look like this, the limit as x goes to a of f of x equals a limit. However, if the f at a is not equal to the limit, these two together give us something that looks like this. There's a limit exists, but the actual coordinate doesn't exist in there. So that's a removable discontinuity. So the easiest way to show a discontinuity is just the fact that it doesn't exist. It means it must be a gap. We could also have this situation, okay, that where we have a limit coming to, that the limit does exist, but the actual point doesn't exist there. So then to provide an argument that a graph is continuous at x equals 2, well, in this case, the graph is continuous at x equals 2, okay, it is at that red point continuous, okay, we could just say this. To show that it's continuous, we're just going to say that the limit as x approaches 2 of f of x is equal to, and it actually equals a value, looks like x equals 3. And we can also set and f of 2 is actually equal to 3. Those two together, this means it's continuous. Okay, so we need both of those conditions satisfied for continuity. Now, this graph is not smooth. It's got a kink at that same point at x equals 2. So how can I provide an argument for this? Well, the argument would be this. The limit, we would provide a slope argument here because what's happening is the slope is not smooth through there. So we can say that the limit as x approaches 2 from the positive side of f prime of x, now we're making a slope argument, is not equal to the slope as it approaches 2 from the negative side. So if these slopes are not the same, although it's defined at that point, it's continuous at that point, the slopes are not the same through that point. That means there must be a kink. There must be an abrupt change in the slope or a kink in the graph. So this indicates there is a kink in the graph.